Today I'm returning to the Alpha Centauri and Barnard star systems, but not without a reason. Updated mods for these systems were recently released in the Steam Workshop, and the planets there now look really interesting. I've left links to these systems in the description. Let's take a look at how they look now and see it all in the SpaceEngine planetarium. And we'll start our journey with the Alpha Centauri system. You just witnessed the bright star Alpha Centauri A, and Alpha Centauri AB is currently orbiting around it. This is a cool sub-Jupiter, a gas giant. This is only a candidate planet as of the filming of this video. It became like this in 2021. The diameter is 145,000 kilometers and the mass is 0.37 of Jupiter's mass. The planet is flattened at the poles, but a day on the planet is 15 hours. Strange, why is the planet so flattened then? It's quite cold on the planet. The average temperature is minus 78 degrees Celsius. Alpha Centauri is the closest star system to us, and there are as many as 3 stars in this system: Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. It orbits just very far from those stars. Let's briefly look at the star Alpha Centauri A. It's the main star of this system. Its type is a yellow dwarf. This star is slightly larger and more massive than our Sun. The temperature is almost the same as the Sun's. Now I'm flying to the star Alpha Centauri B. Its type is an orange dwarf. This star, on the contrary, is slightly smaller and lighter than our Sun. The temperature is the same. There's one planet in its orbit called Alpha Centauri BB, but this planet doesn't exist, so it's an unconfirmed candidate planet. But the author of this system on Steam decided to keep it. This planet isn't very large, rather, it's a dwarf planet with a diameter of 3,800 kilometers and a mass slightly less than 3 moon masses. It's tidally locked to the star and always faces it with one side. There's a thin atmosphere consisting of octane. The atmospheric pressure is very weak and the average temperature is 400 degrees Celsius. A hot planet. Such a landscape opens up on the surface of this planet. We see a thin atmosphere in the sky, but it's so thin that it gives the impression that we're in outer space. The surface has melted from the high temperatures. In this spot where I am now, the temperature is 850 degrees Celsius. And this is how the star Alpha Centauri B looks in its sky. The distance to it is just under 6 million kilometers. And here's a view of the neighboring star Alpha Centauri A. In the zone of eternal twilight on this planet, I found such an interesting place. A canyon here. Rays from the star fall on one side of this canyon, and from this spot you can see the third star in this system, Proxima Centauri. There it is actually, and as you can see, it's very faint and dim, and on top of that, situated very far away. The distance to it is as much as 0.13 light years. And since I've started talking about Proxima Centauri, it's time to visit it. This star also has a special status for us Earthlings, as it's the closest star to our solar system, located at a distance of just over 4 light years from Earth. The star Proxima Centauri is a red dwarf with a diameter of 214,500 kilometers and a mass of 0.12 of the Sun's mass. The surface temperature of this star is 2,769 degrees Celsius. There are 3 planets in its orbit. The third planet, as you can see, orbits very far from the first 2, while these first 2 planets orbit very close to the star. And the first planet in its orbit is called Proxima D. Its class is a warm desert Terra, discovered in 2020. It has a diameter of 10,300 kilometers and a mass of 0.35 of the Earth's mass. It is tidally locked to its star and always has one side facing it. There is a fairly dense atmosphere consisting of carbon dioxide and water vapor. The atmospheric pressure on the planet is 14.5 atmospheres, and the average temperature is 86 degrees Celsius. It's quite hot there. On the surface of this planet, there's a landscape like this. The surface is yellow, something like a desert, mountains are visible in the distance, and there are dense clouds in the sky. By the way, I'll speed up time even more to see the movement of these clouds. And there's some kind of earthquake here. It's unclear why the surface of this planet is behaving this way. The star looks like this through these clouds. The distance to the star here is more than 4 million kilometers. On this planet, there are also these rocks and crevices. Everything is so craggy here, it's even a bit scary. Let me descend into one of these cliffs and see what kind of view opens up there. For example, right here. And this is what it all looks like. Such majestic high mountains. Wow, it truly looks completely mesmerizing. And those clouds racing across the sky. I've traveled to the Terminator zone on this planet, where eternal day borders eternal night, and here we can see how the star Proxima Centauri appears at sunset on this planet. Since the planet is tidally locked to its star, a sunset is unlikely to happen here, but it's actually worth a try. I'll try to speed up time and check it out. So I'm speeding up time, speeding it up a lot, and incredibly the star here goes below the horizon, but as we can see, not very deep. Over time the star rises back up in this spot. This planet has completely zero axial tilt, but the fact that the star could set here strongly suggests that the planet's orbit likely has a noticeable eccentricity or a slight orbital inclination, or it's related to something else. If you have any other thoughts on this, I'd be happy if you shared them in the comment. And from the surface of this planet, we can see the neighboring planet Proxima b, so I'm flying over there. Proxima b is a cool lacustrine terra. It was discovered in 2016. The diameter is 16,692 kilometers, and the mass is 1.45 of the Earth's mass. So the planet is larger and more massive than our planet. It is also locked with one side to its parent star in a tidal lock. There is liquid water on the surface, which is already interesting. There is an atmosphere consisting of carbon dioxide, water vapor, and sulfur dioxide. The atmospheric pressure is 0.65 atmospheres, and the average temperature is minus 38 degrees Celsius. Here we see the terminator zone on this planet, where eternal day meets eternal night, and we see that there's ice, an icy strip running through there. I've landed on the surface of Proxima b, quite a place. Here we have a view of one of the bodies of water on this planet. I'm standing on a mountain peak, and there's some kind of earthquake happening on the surface here too. Here's a good view of the star Proxima Centauri. The distance to Proxima Centauri is just over 7 million kilometers. And right nearby, you can see the neighboring planet Proxima d. This shaking is getting annoying, so I'll stop time. It all goes away, making it much more comfortable to watch. Anyway, I've landed near a body of water, and the temperature here is over 1 degree Celsius, and I'll also descend into the terminator zone to show you the view of the star. This is the view of the star from here. I'll try speeding up time here. Maybe the star sets the same way it did on the first planet in this system. Yes, look, there's actually a slight movement of the star, but here it doesn't reach the horizon. I have traveled to the dark side of Proxima b to show you how the stars Alpha Centauri A and B look from here. There they are, shining brightly like a single star because they are so close together and seem to merge from this vantage point. But if we zoom in with a telescope, we'll certainly be able to distinguish these two stars. There you go. Now I'll head to the last planet in this system, which is far away from Proxima Centauri. This planet is called Proxima c. It's a gas planet, classified as a cold sub-Neptune. It was discovered in 2019. Its diameter is 32,638 kilometers, and its mass is 7.78 times that of Earth. It's very cold here, with an average temperature of minus 228 degrees Celsius. But interestingly, this planet has its own ring system. Flying inside these rings, they rotate very quickly around the planet. This is in real time. Now I'll slow down time below real time, and we can see this kind of beauty. I'll switch back to HDR mode, and this is what the rings look like. It looks absolutely gorgeous against the backdrop of the planet, but we can see that these rings aren't actually that thick. And now let's head to the next star system. That would be Barnard's star system. Barnard's star is a single star located just under 6 light years away from our solar system. It's a red dwarf with a diameter of 247,600 kilometers and a mass of 0.16 of the sun's mass. The star's surface temperature is 3005 degrees Celsius. 4 planets orbit this star, and the creator of this system on Steam wrote that they've all been discovered. Here you can see the orbits of these planets. And the first planet in this system is called Barnard Star D. It's a warm desert aquaria with a diameter of 8,842 kilometers and a mass of 0.26 of Earth's mass. The planet is tidally locked to its star and always has one side facing it. It has an atmosphere consisting mainly of water vapor, but the surface atmospheric pressure is a whopping 4,342 atmospheres. Incredible! The average temperature is 136 degrees Celsius, such a scorching hot planet. I've landed at a completely random spot on the equator, and we see this desert surface, everything in yellow shades, both the surface and the sky. I see a dot over there. That's a neighboring planet in this system. And this is what the star looks like. The distance to the star is listed as 2,823,000 kilometers. The planet also has its own mountain ranges. This is how they look. I've descended into a mountainous area. There are these yellow mountains here. It's interesting for sure. I've moved to the top of this high mountain, and we see this landscape stretching into the distance. And just look at how beautiful it is. I'm near the Terminator zone, trying to descend to the surface, but I stopped because of this incredible beauty. And here I am, actually on the surface in the Terminator zone. We see the star right at sunset, and I'll try speeding up time to see if there's any movement, speeding it up a lot. Yes, there is some, but not very much. I've slowed down time to get a better look at this process. The star didn't set completely here, unfortunately, but I'll find another spot. I've flown back a bit, and speeding up time, we see the star setting below the horizon, but the twilight here will remain just as it was. Also, I think it's worth showing you that this planet has its own auroras. This is the beauty you see at one of the poles. And now it's time to head to the second planet in this system. The planet is called Barnard's Star B, a temperate marine terror. It was discovered in 2018. The diameter is 9,174 kilometers, and the mass is 0.3 of Earth's mass. It is also tidally locked to its host star. There is liquid water present on the surface, along with an atmosphere composed of carbon dioxide, water vapor, nitrogen, and hydrogen sulfide. The atmospheric pressure is just under 1 atmosphere. Oh, now that's interesting. And the average temperature is just over 1 degree Celsius. And here we see this liquid water on the surface. I'll descend there right away, and here you go. This liquid is rippling on the surface, but mostly, as we see, it's a desert landscape here with these gray clouds. I see mountains in the distance. Let's head straight for them. The cliffs here are quite high and sharp. Well, if you pan the camera around, there's certainly plenty to see. And from up here, you get this view of the body of water. I'll show you the star again, how it shines through this atmosphere. That's Barnard's star. The distance to it is just over 3 million kilometers. In this spot where I am, the temperature is 69 degrees Celsius. The overall average is just over 1 degree. But since one side faces the star, it receives much more stellar energy, so this part heats up much more. Descending from the mountain, the temperature here is 110 degrees Celsius. And also here on this planet, in the Terminator zone, we see this ice cover, and I even see cracks on the surface here. Let's head over to that crack. And look, I'm right on the edge of this precipice. What a sight. And here we see the star at sunset. This is the Terminator zone. This is the view of the sky here. I see a bright dot. What is it? A neighboring planet in the system, yes? And this view of the star. Speeding up time, as is the tradition in this video. Let's see how it moves here. Well, you see there's that slight movement, typical, I assume, of all tidally locked planets. It is time to head to the next third planet in this system. The planet is called Barnard's Star C. This planet's class is Temperate Desert Terra. It was discovered in 2025, quite recently, I would say. Its diameter is 9,467 kilometers, and its mass is 0.33 of Earth's mass. It is also tidally locked with one side facing its star. There is an atmosphere consisting of carbon dioxide, nitrogen, and water vapor. Atmospheric pressure is almost 8 atmospheres, and the average temperature is nearly 39 degrees Celsius. This is the view on the surface. Everything is yellow, both the surface and the sky. Well, it is a purely desert world. I will speed up time. Let's look at the movement of the clouds. These beige-yellow clouds are racing across the sky. And how does the star look through these clouds? There it is clearly visible, and the distance to Barnard's star is just over 4,248,000 kilometers. On the planet, I see what looks like many extinct volcanoes. Here is one of them. I will descend here. Wow, they are so high that it is as if I have ended up in space. Look, the atmosphere is not visible at all. The height of this elevation is as much as 20 kilometers. Okay, I will go lower and check what the difference is if I descend. Well, yes. Look, it turns out that these mountains on the extinct volcano, or whatever it is, are simply higher than the main cloud layer here on this planet. And here is just the edge of these clouds. I will fly lower now, and here we are just entering the clouds, and we have flown through another cloud layer. Yes, it is really very high there. I see that all the planets here have auroras. I will descend somewhere near them into the Terminator zone. I have found a good spot for a view of the star. There it is, half peeking out from below the horizon, you could say. Here are those passing clouds. Let's see if the auroras I told you about are visible. No, they are not visible here. Oh well. Anyway, I am speeding up time, and let's see if it will move here. We are already used to these stars moving everywhere, and this planet is no exception. You see, there is movement here as well. And when the star completely sets below the horizon, I will stop time. We see an aurora appearing here. Well, yes, we are not far from one of this planet's poles. I will speed up time more, and we see the movement of the auroras and clouds while the star is already below the horizon. If I speed it up further, it will come back out again. Well, that is all clear. We see two bright dots, Barnard's Star B and Barnard's Star D, the previous planets we examined. But in this system, there is one more planet called Barnard Star E. This is the last planet of this system. It was discovered in 2025. It is a rocky world 8,116 kilometers in diameter and with a mass of 0.193 of Earth's mass. It is also tidally locked to its star. There is an atmosphere consisting of carbon dioxide, ethylene, acetylene, ethane, and nitrogen. Atmospheric pressure is very weak and the average temperature is minus 135 degrees Celsius. This planet's class is called Desert Subaquaria. Oh, well, it is at least more interesting here. There is a yellow desert surface, but the sky at least has purple hues, and it is already more interesting on this planet. Wouldn't you agree? I'll look for a star in the sky. Here is actually Barnard's star, and since this planet is the farthest one from this star, the distance to the star is just under 6 million kilometers. And look how great everything looks here. The whole system is right before your eyes. There is the central star, and we see 3 planets lined up in almost a perfect row. Now that's really cool. On this planet, we also see that there are extinct volcanoes. We can clearly see a volcanic crater and mountain ranges. I want to descend onto one of the mountain peaks. What a cool landscape here in the mountainous areas. A very good view of the star. I am very curious if I speed up time here. I assume we will be able to observe the movement of neighboring planets from this vantage point with clarity. The star is moving a bit too, and well, the movement of the planets. It looks amazing. In the Terminator zone, there's this, as I said, view of the star. Speeding up time. Let's take a look. Yes, there the star sets below the horizon and rises again. Well, on planets with tidal locking, I suppose it's normal that they can set and rise like this in some places. It's cool, isn't it? But honestly, to see these sunsets and sunrises, you have to speed up time significantly. That's the kind of journey we've had. I hope it was as interesting for you as it was for me. If you enjoyed it, please support the video with a like and leave a comment. Thank you very much.